Hey everyone, welcome back to the channel. And today we are going to solve reschedule meetings for maximum free time 1, which was the second problem in bi-weekly contest 149. Okay, so here we are given a list of events and a time frame, which is starting from 0 to event time. And we are given some events in between here, which each event has its own start time and end time. So in the first example, we have this first event, which start time is 1 and the end time is 2. Right, start time is 1 and end time is 2. For the second event, the start time is 3 and end time is 5. So we have to find the maximum free time which we can get by moving at most k events in either direction. So let's say in current scenario, how much free time we can get. So this is free time. As you can see, the gaps in between these two events or the start time or event time. So this is 1, this is 1. So in the current scenario, the maximum free time which we can get is 1, right? But here they are allowing us to move at most k events such that we can maximize our free time, right? But the catch here is we have to maintain the relative orders of this event. So we shouldn't be moving this event to this position because that will change its relative order. This will become 2, 1. But it is not possible because we have to maintain 1, 2 as a relative order of these events. So from this, we can say that we can move each event in either direction until it not passes the second or the neighbor events, right? Okay. So in order to find the maximum events, let's first consider all the free times available in this scenario. So we will initialize a gaps variable, which we will accumulate all the free time available in between the events. So what will be the first free time available? That would be the start time, which is 0, and the starting of the first event. So 1 minus 0, that would be 1. What will be the second gap which we will get as a free time? That would be the start time of second event and the end time of the previous event. So the start time of this second is 3 minus end time of the first event is 2. So that would be 1 here. What would be the last gap which we can get? So see, our event would only be happening until the last event time. In the first example, our last event time is 5. So here our event ends. But let's say if our event ends at 6 and the last event which was ended at 5, then we can get this as a free time. So what would be the last free time which we can get? 6 minus the end time of last event. That would be 1 as well. So in the current scenario, the maximum consecutive free time which we can get is 1 only. So we have to maximize this gap. How many ways are there in to maximize this event gap? Okay, so there are two ways. First, we can move this event to anywhere, like pick this event and throw it away in some other places. So thereby we can get 1, 0 to 3. That means 3 minus 0 would be 3 as a free time. Free time. What will be the after scenario if we move this event to, let's say, this position? That wouldn't be maintaining its relative order. So, okay, so first approach wouldn't be working because we have to maintain the relative order. As this would violate the relative order rule, this is not possible. What would be the second approach? The second approach would be maintaining the relative order of the events, but moving just ahead or uh, backward in the timeline. By that, we can maintain the relative order of these two events, but would we would be maximizing this gap in between. So let's say if we move this first event to backward position, so it will be here. So the maximum gap which we can get now is 2. So by this way, we can increase the gap. What if we move it in the forward direction? This way only, we will be only getting 2 as a gap. Right. So have you seen what is happening here? The maximum gap which we can get by moving any one event would be combination of the two gaps which was present there. So here we have just summed up two gaps, 1 plus 1, which was there. So here was one gap and here was one gap. So by moving this event to either side, we are just summing up the gaps which was there before the event was occupied that gap. So this event occupied the space here. And this was the second gap. So our gap list would be, what was our gap list? So we had 1, 1, 0 as a gap list. So by moving this one event, we are just combining the consecutive gaps which was thereby. How much events we can move? We can only move at most k events. What does this mean? Let's say if we are moving one event, then we can combine two gaps, right? Let's say we have one, two, three events. 1, 2, 3, 4, 5, 6, 7, 8. Right? What if we have k is equal to 1? We can only move either this event, or this event. Right? If we are just moving this event, let's say to the extreme left position, then we would be getting this as a gap. That would be the maximum two gap because previously 1, 1, and 1 was present. So our gap array previously was 1, 1, 1, and 1. Right? What if we move this event to extreme left position? We would be combining this one and this one. Right? So you can consider it as we have just moved this gap to this position and this event to this position, right? So that would be 1 plus 1 to 2. So we have just summed up these first two gaps. What if we have k is equal to 2? If we have k is equal to 2, then we can move these two events or these two events, right? Let's consider if we are moving these two events, right? So in order to maximize this gap in between, we can move them in either direction. Let's say what would be the maximum gap if we can move these two events to far most left, right? That would be, we would be getting the maximum gap at that way. So after that, this would be the scenario. And we can get 3 as a maximum gap, right? So can you observe what happened here? So the gap which was here moved to here, gap which was here moved to here. This is also the as is gap. And we have just combined this, and these gaps. So if k was 2, then we were able to combine this, and this. So the sum of these three values, which is 3. So by this way, we got to know that if there are k events which we can move, then we can combine k plus 1 gaps, right? Okay, so now you would be clear that what are our steps. So we have to accumulate all the gaps first. Then we will initialize our max gap variable as maximum gap available in the current scenario without moving any of the event. Then we can go through each gap and then we can use sliding window here. Sliding window that is of size k plus 1. And then we would be summing up all the gaps of the k plus 1 size. And then we would be finding the maximum sum of this gap, which we can find through this sliding window. Right? So let's move to the coding part. So first we have to initialize a gaps variable, which would be a list. Then we will add our first gap as start time of first event minus 0. Then we will go through each event. Let's initialize our size variable as length of each event. Length of all events. That would be length of start time or let's say end time. These both will be similar. So we can pick any of them. Okay, so how we are going to add the gaps in between each event? So that would be start time of first event minus end time of previous event. So for this to work, we have to initialize our I variable from 1 so that this condition would be satisfied. Okay, so what would be the next step? Then we have to append the last gaps which we can get. That would be event time minus the end time of last event, right? Okay, Now we have to go through each gap with the sliding window of size k plus 1, right? So let's initialize our sliding window variables: start time, end time. So end time we would be picking from each index in gaps variable. Okay, so start is 0. We would be also needing a gap sum, which we will initialize as 0, and maximum gap sum as 0 as well. We have to maximize this gap sum in order to get the maximum consecutive free time which we can get by moving any events. So let's add the current gap in the gap sum. Okay, but what if we exceed the sliding window from size k plus 1? How can we get the length of our current sliding window? That would be end minus start plus 1, right? So if we are exceeding that, then we have to reduce it by the last start time which we picked up and increase our start variable, and then we have to check our gap sum with maximum gap sum. If that is greater than maximum gap sum, then we will just assign it to max gap sum. Then we can return maximum gap sum. Let's check if this is correct or not. Okay, this was a typo. Okay, so it's accepted. Okay, so you can see this is working. So what would be the time complexity? So time complexity would be O of n here, as we are going through each event. So there can be n events, so there would be n plus 2. So this is 1, 2, and other n events for each event. So this would be equal to O of n. And this operation would also be O of n as we are going through each gap. So time complexity of this solution would be O of n. What would be the space complexity? So space complexity would be also O of n, as we are just using a gaps list to store our each free time in between the events. So let's say there are n events, so there can be at most n plus 2 events. So space complexity would be also O of n. If you got any questions or feedback, drop them in the comments. I am here to learn and share with you. Alright, that's it. Thanks for watching. Catch you guys in the next one. Peace.